Introduction to Performance. In this video, we want to understand what is the meaning of performance. Actually, there are many different ways to understand this concept. So let's start with the first view of performance. How to define performance, or how to define a measure for the performance. First, we want to look at its property. In order to give a good description or good definition, so we want to look at its property first. Here, I list several basic facts about performance. First, the better the performance in computing, the smaller the response time, right? So when we run a program, if we say this program has very fast performance, that corresponds to the response time is very fast. So that's one simple fact we have. The second one, so we may use the response time to define performance concept. Because the response time, there is a simple measure there we can use directly. But the performance, at this point, there is no measure for the performance. There is no natural, simple, direct measure for the performance. So how do we define it? So the first idea, just use the response time. Okay? So the most straightforward way to define performance is using the response time. But how do we use it? So let's look at the next fact. It seems that these two measures are inversely proportional. So in order to use the response time in the right way, we want to look at their relationship. Inversely proportional. Not proportional, inversely proportional. Or reversely. So I don't know. So the right word, reversely, probably reversely is a better word than inversely. Anyway, reversely or inversely, proportional. Okay? All right, so reversely proportional. So the larger the response time, the smaller the performance. Or the smaller the response time, the faster the performance measure. So that's the relationship. So with this kind of understanding, so our first view of performance, it's very simple. We just create a new performance measure. It's called a performance. Performance equals the reciprocal of execution time. How about this one? Reciprocal, because if we use this way, we get reversely proportional relationship, right? Reversely proportional. Relationship. So this is based on these three simple facts, we can summarize our first performance measure. Next question. Is this definition reasonable? Is this definition, we are very happy with it? When you use it, try to understand the computing performance. If you use it to try to understand the performance issue in computing, sooner or later, you may have problem. So that's based on my own experience. Yeah. Yeah. When I taught this topic many times before, at some point, suddenly I realized something must be wrong. So that's my own experience. So let me talk about that here. Discussion a little bit. Yeah. First, is the performance only determined by execution time? Yeah, because based on this formula, reciprocal of execution time, here the performance is only determined by execution time, right? Yeah. But in our real world applications, can we say the performance is only determined by the execution time? It's not. Yeah. It's not that simple. Yeah. Yeah. Look at this. Why we cannot see the amount of work in the computing task, right? We couldn't, so in this formula, we couldn't see amount of work. Or in our textbook, it called workload. We cannot see the workload measure. Yeah, we don't know how to measure workload, but there is a workload factor there, right? But we cannot see in the formula. Now, here I can give you a simple example. So you will see this measure is not quite right. Yeah. So let's compare. All right. So let's compare two programs on their performance. Okay. Let's assume two programs how do we say that? Yeah. The performance. Right. All right. So two programs solve the same problem, but the workload is different. How about that? The workload is different. Okay? Can we compare their performance? The workload is different. Okay? Yeah. For example, let me just imagine the first program needs to do 3 million searches. Yeah, search operation. How about that? Search operations using 2 seconds. Okay, so the first program. The second program do 1 million search operation, same search operation, okay, but in 1 second. If we compare these two programs, which one faster? Which one should have faster performance? So you can see immediately, right? Yeah. The first one has faster performance. Yeah, 3 million in 2 seconds. Yeah. So double your execution time, but triple the number of operations the first one can process. Right. So if you compare in that way, definitely the first one is faster. But if you use the measure here, reciprocal of performance, the first one 1/2 the measure, the second one 1 is bigger than 1/2, right? The performance measure, it looks like the second one is faster, right? That's ridiculous. Yeah. So that's the reason. So this definition, this understanding is not right. Is not right. Yeah. 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 All right. So let us go back to our textbook. Yeah. So the authors noticed this issue. I think the authors noticed this issue. Yeah. Yeah. So view on alternative performance metrics. Yeah. So that's the reason. Yeah. Starting from the 5th edition of the textbook, the authors added a paragraph to explain this issue in an abstract way. Yeah, it's not a direct, straightforward way, but in some abstract, vague way. Yeah. So I copied that paragraph. I put it here. Yeah. So this is the paragraph from the textbook. Yeah. Our position is that the only consistent and reliable measure of the performance is the execution time of real programs, and that all proposed alternatives. So this is proposed alternatives, right? One of the proposed alternative performance metrics. Yeah. All proposed alternatives to time as the metric have eventually lead to misleading claims. Misleading claims. If we use this understanding, sooner or later, we will get some ridiculous results. Yeah, I got that. Yeah, I got some, ridiculous results. Yeah. So the authors noticed that. Yeah, I believe many instructors notice that and reflect the problem to the authors. So they add this paragraph and put explanation here, although I feel it's still a vague explanation. Yeah. Eventually lead to misleading claims or even mistakes in computer design. Mistakes, see? So this measure could cause mistakes in computer design. So it's a big problem. See, big problem. Yeah. Yeah. But it does not mention this definition, right? It just say general alternative performance metrics other than execution time. Execution time looks safe, looks reliable, but this one does not. Okay? Yeah. All right. I also give the reference in the textbook. So section 1.8, page 39, you can find this paragraph. Yeah. Anyway, so I give you the comments. So based on this, it means I will not give you questions using this formula, okay? Because it's a bad formula. So if I create questions based on this formulas, you will see some results ridiculous. Yeah. All right, so let's move to the next topic. Yeah. All right, still, when you compare performance, so let's look at this measure another time, the last time. Right? When we compare the performance, we can compare through execution time. But when we do this, keep in your mind, based on the analysis in our previous slide, you can see, keep in your mind the same workload, okay? Same workload. Do not use different workload, okay? 3 million search operations, 1 million search operations, the workload different. How can you compare, right? Yeah. How can you compare response time in that way? Okay, not fair. Yeah. All right. Similarly, for the performance, reciprocal, so we can do, mathematically, we can write in this way, right? But remember, there is some hidden condition, same workload. Otherwise, you will get trouble. Okay? So the workload, you will get trouble. Yeah. All right, so we finished this topic. Yeah. But as our first view of performance, later we will have many different views, many different definitions, metrics on performance. Yeah. All right, so next we will move to the next performance metric. Yeah, that one will be much better, but we'll spend a lot of time to learn that. Yeah. First, the concept, clock cycle. I mentioned that before. Inside CPU, there is a special clock different from our regular clock, but there is a very important clock. It's there. Yeah. Yeah. And the unit, yeah, every time the clock moves forward 1 unit of time, so that unit of time, clock cycle, CPU clock cycle, usually in in the range of nanosecond, ns, in the range of nanosecond, that fast. Yeah, so you get an idea how fast the CPU clock is. Yeah, all right. Essentially, all computers are constructed using a clock running at a constant rate. You may ask why we need to put a clock inside CPU. Because in order to execute all the operations, you need to use a clock to make controls. Otherwise, how can you control? When should you do the first operation? When you should do the second operation, and so on, right? Without a clock, you do not know when to start your certain operations. Yeah. All right. Yeah. So the CPU requires a fixed number of clock ticks. Yeah. So there are several names: clock cycles, clock ticks. Okay. Yeah. There is another name. Yeah. I forgot. Yeah. Anyway. Yeah. Most of the time we just call clock cycle. Yeah. To execute each instruction. Each instruction, all right, one instruction. Yeah. Machine code, machine language, one instruction, CPU. Yeah. It takes certain number of clock cycles to complete. Yeah. Some instructions more complicated, so we need to use more clock cycles. Some instructions relatively easier, so we use fewer number of clock cycles. Yeah. So that's the basic fact. The faster the clock, the more instructions the CPU can execute per second. Yeah. The faster the clock cycle time is smaller. Yeah. The faster the clock. Yeah. So you use the same number of clock cycles to complete one instruction, but you need shorter time, right? The faster the clock, shorter time. Yeah. So then in 1 second you can execute more instructions. Yeah. The faster your computer is faster, your CPU is faster. Yeah. All right. A clock cycle, or simply a cycle, yeah, in this context, yeah, we just use cycle, yeah, is a single electronic pulse of a CPU. Yeah, yeah. So, by physics, yeah, a simple pulse, yeah, electronic pulse, yeah, something like that. Yeah. All right. So during each cycle, a CPU can perform a basic operation such as fetching an instruction. Yeah. The operations like basic things we will learn details later. Yeah. One instruction can be broken into several pieces. Yeah, because in one instruction, there are many things to do. Yeah. So you have to do, based on some smaller segments. Yeah. All right. So here, give you example. So what kind of smaller segments, right? Yeah. So here, some examples. Fetching an instruction from main memory to CPU. Yeah. So this one. Yeah. The source. Yeah. From memory. Yeah. Memory to CPU. Fetch. Originally, instructions are in main memory. Yeah. Loaded from main memory to CPU. Yeah. Later, you need to go through cache. Yeah. Main memory to cache, then to CPU. So later we will add to cache, then CPU. Okay? Yeah. Yeah. All right. Accessing memory. Yeah. After you load instructions, you need to do calculation, right? When you do calculation, you need to load the data, right? The data also stored in main memory, so you need to access memory. Load the data and write data, okay? Yeah, access, yeah, or writing data. Yeah. Accessing memory, read and write, yeah, yeah, things like this. Yeah. So there are many things you need to do. Yeah. So we delay that part. Instruction, operation, details. So we will spend a lot of time to learn that. Yeah. All right, so next. Another important concept, clock rate. Yeah. So for this concept, yeah, the definition, yeah, it's pretty straightforward, yeah, pretty easy. The clock rate or clock speed, yeah, yeah, typically refers to the frequency. Frequency, yeah, yeah. So there is a special meaning about frequency. Yeah. When we talk about frequency, usually we mean in 1 second, yeah, in just 1 second, how many times do we have this thing? Yeah, this thing happen. Yeah, usually we mean in general. So here, frequency. In 1 second, how many clock cycles do we have? That's the clock rate. That's the definition of the clock rate. Yeah. All right. So this clock rate, important, it is used as an indicator of the processor's speed. Now, CPU, yeah. Speed, how fast? Yeah. The faster the clock rate, the faster the CPU, yeah, in that way, yeah. But there is something more on that understanding. Yeah, we will see that. Yeah. The formula is this. Clock rate equals 1 over clock cycle time. Okay. Here you can see, yeah, clock cycle time, usually it's a fraction of, certain fraction of nanosecond. NS, but 0. something nanosecond. So that's the clock cycle time. 1 over that, yeah, because nanosecond equals 10 to the negative 9th second, right? Yeah. So 1 second over that, right? 1 second. In 1 second, that reciprocal, that one means 1 second. 1 second over that, so you get a certain number of, yeah, certain number greater than 1, yeah, because 1 over 0 point something, that number greater than 1, that number gigahertz, yeah, because 10 to the 9th hertz, the unit is hertz, number of times per second, hertz, so the gigahertz, GHz. Yeah, so that's the clock rate. Yeah, usually you see. So it is measured in clock cycles per second or hertz. But that number usually is really big, so people use gigahertz. Yeah. All right. Usage. What is the right way to use this concept? Yeah. The clock rate of a CPU is most useful for providing comparisons between CPUs in the same family. Yeah, that's important. Yeah. Otherwise, if you compare different types of CPUs, then you cannot get good conclusion. Yeah. Yeah. So same family. Yeah. Yeah. So same type of CPU, but evolves in different generations. So then you compare, right? So improve. Yeah. So basic things the same, but improvement reflected in clock rate. Then you can compare. But different types of CPUs, right? Yeah. So then, if we only look at the clock rate number, so it's not a fair comparison. Yeah. So this sentence tells you that. Yeah. Same family. Yeah. The clock rate is only one of several factors. Yeah. There are several factors, but this one is one of those factors that can influence performance when comparing processors in different families. Yeah. So eventually we need to compare processors in different families. Yeah. So then you need to consider other factors. Yeah. Yeah. All right. So here, this is a general discussion about these basic concepts. In the next video, we will learn a new performance measure. Yeah. Mainly, we are looking at the performance of CPU. Yeah. All right, so let me stop this